talking about how we can help people do their survey astronomy. The data numbers now are ever increasing, and so how going forward we might have to change the way we work and how we provide access to the data. For those of you who don't know where the observatory is, we're in Edinburgh, on top of the hill, overlooking our own volcano, but thankfully this one's it's been extinct for quite a while now, so we don't have the problems that might face people here. We started out, the first archives we worked with, we started out as the UK Schmidt telescope unit, and as part of that we had the Supercosmos measuring machine, so not a true digital survey, but a digitized survey. And as we've gone forward now, we have a staff with a mixture of backgrounds, astronomers, research astronomers, PhDs, postdocs, but we're sort of leaning towards more development now, computer programmers, just to deal with the new sort of computing challenges we're now facing. And as this is a celebration of Massimo's birthday, I thought we would try and see if we'd ever supported Massimo in his research. So I went down to the basement and found an application from 33 years ago, the UK Schmidt plate material, which thankfully Jerry approved, otherwise this would be embarrassing. The plates were duly taken, and I think looking in the folder, you seem to produce lots of papers from that work as well, so it was, that was just an early example. Things have changed obviously going forward. We used to send the plates out by post and to the users. Of course, now everything's fully digital and available online for users to query. The first fully sort of online was the Supercosmos scans of the Schmidt plates. So this is all sky coverage in 3 bands, BR and I, and 2 epochs in the red. That's still used a lot. We still get over sort of 10,000 queries a month on that data. And that's also linked into other archives and sort of facilities. Skyview uses the data and things like that. Moving on to sort of more modern era surveys, we host the WIFCAM Science Archive, which is mainly for the UKIDS sort of large surveys or some of the deep surveys as well. That work was done as part of the VISTA data flow system as a precursor to what went on to be the VISTA Science Archive. And we kind of kept that same model going, the same pipeline, and we now archive the AmigaCam Science Archive, as it's called, but that's mainly a VST Atlas. Smaller sort of data numbers, but we now also do the GES spectroscopic archive, and try and add value to the archives we host. We also keep copies, our own copies of some of the more obvious external surveys, Sloan, 2MASS, WISE, GLIMPSE. Usually we get requested if we can add in things, so we try and, if we have the space available, we'll add them in. But again, that sort of thing might change, and I'll talk about that a bit later as well. So just briefly describe the data flow system in place at the moment. The RAWs are transferred to Cambridge from either WIFCAM or VISTA, and now VST as well. They run the reduction pipeline down there, and then we transfer up the fully calibrated images and catalogs. We transfer everything. We transfer the calibration files, the darks, the flats, but mainly it's the fully calibrated catalogs that are most sort of useful to the typical user, but obviously the images as well. We then ingest all that metadata from the images, the object catalogs themselves, into relational database system. And then further down the line, we do quite detailed quality control on the data at the frame level. So some frames are rejected and not published, though they're still available in the archive. We don't throw anything away; everything's there, but it doesn't go into produce the science sort of releases. We band merge the different filters. Cambridge, they stack on a nightly basis, but we further deep stack for projects like DXS in UKIDS and VMC and VVV in VISTA. We also produce more added value. We produce the neighbour tables with the external surveys we host. We carry out a variability analysis, produce variability tables for VVV and VMC. And then the final stage is to actually publish those database releases Typically, initially, they're released to the consortia, and then after a proprietary period, they're released to the world, and anybody can access them. So just some of the numbers now that we have. We're almost up at a petabyte of data. So, you know, but things are only going to get worse. So this is quite good now. Numbers are starting to get even more scary. Of that near petabyte, a third of it is actually in the database catalogs themselves, the objects. We get over 50,000 queries. That's queries, SQL queries to the object catalog tables. And now our biggest headache is the VVV. The largest table in there is the detection table. That has 19 billion rows, and that's proving quite a challenge to computationally to keep going. So we might have to sort of develop new techniques to keep going with that. Although it's a reasonably small area, they're observing some fields 100 times, so we're just having more and more detections going into the table. And then we're serving out those data on 2 billion rows a month at the moment. And like I said, we serve the images as well, cutouts, serve the whole frames. But like I say, the VVV is dominating. It accounts for amount of data of all the others combined. So we've been now working with the community for over 25 years. We like to think we produce high quality science-ready data releases, and I think that's very important. QC, you know what's gone into the surveys, what's been published. We flag individual objects as well as the frames. If there's confidence in the image, there's a confidence bit flag set, you know, coming from the data reduction. And we like to think, we followed the Sloan model for the SQL kind of interface, so that's what most of our users use now. It's powerful, you can data mine, you can search parameter space, and we've also been trying to build in the standards of the VO as well, so all the public archives we produce are available directly through the VO. And then, like I said, we're adding new data with the deep stacking, we provide proper motions for some of the surveys, the variability, and then we try and provide a good service as well from the help desk point of view. So although I'm talking about what we do, this is sort of applicable to any data archive or science archive. And now just talk a little bit about what our current development. Most of what I've talked about has sort of been stable now for the last sort of 5 or 6 years. But we're finding now that users are wishing to sort of query more complex queries and more iterative queries. So they want to search a data set and then maybe refine that or add in another data set and try and bring out more information. Multi-web survey consortia are becoming more normal. Earlier talked about combining satellite data and earthbound data and things like that. So it's increasingly people are trying to bring in more and combine it. And unfortunately, the VO is now mature enough and reliable enough that we can start to build our infrastructure based on there. So going forward, we've changed the user interface a bit. It's still web-based, but we've rolled out for VST Atlas a new prototype, just a bit more functionality in the browser-based thing. You can do plotting within the browser, but underneath now it's all sitting on a VO infrastructure. And then the plan for sort of the coming year or so is to provide even more server-side functionality. I think again, Sloan do this, they do a sort of MyDB, but the idea is to try and expand on that, provide user sort of database for storage of your queries that you've already run, a collaborative space for your sort of groups. And the big thing we're working on as well at the moment is to enable these distributed queries across different data sets that maybe we don't host. We're finding it quite a challenge to keep copies of other external surveys. We can sort of just about cope at the moment, but again, that's only going to get worse going forward. This is just a bit of a plot of the current development sort of phase. We have a new user interface sitting in front of a web, sort of a very thin layer, a web Python service acting as the web server. A lot of work recently has gone into this Firethorn. It's just a name. I think it's the name of a butterfly metadata layer, which tries to understand users' queries, breaks them down, tries to know which tables, etc. they're after, and then the layer that's going to handle the distributed query is the Oxidai, which is, if I can remember correctly, is open grid, service architecture, data access, and integration. And that's a layer written by the Edinburgh Parallel Computing Centre, but we're starting to just delve into that now and extend it a bit just so it can work for our purposes. So a user will submit a query, come through the interface, we'll do a bit of processing to try and figure out what exactly they want, try and decide whether you'll need to know whether the databases are ours, so they're local, whether it can go directly there, or whether they're just databases served in the VO. TAP is the table access protocol for the virtual observatory, and it'll be able to tell where it needs to bring the data from, produce your query, join if necessary, and data is either returned to the user or we will store it in our own system, and again that will be archivable, and groups can collaborate or publish their data, and indeed that will provide a service where they can publish their data straight to the VO as well. So all this is designed to run on the virtual machines, so it's readily sort of deployable in a lot of situations. So what we learned from doing all this for over 25 years, it's good to have involvement throughout the data life cycle. Understand the data, how users want to access it, what they want to do with it. Again, the quality control of it to make sure it's a fairly standard and homogeneous data set that users are dealing with. A few bumps we've hit along the way is when we've received a big reprocessing of the data. So we've had 4 years worth of data from Vista. We've had to go through it all again because things have changed. That set us back quite a lot for the VVV. And again, provide good help desk service to our users. And increasingly, with data sizes just getting bigger and bigger, the analysis must move increasingly to the data center. It's the only way of handling that sort of volumes. You're not going to be able to pull it all across to your laptop and work with it. Okay, thank you.
Okay, well, thank you very much, Mark. Any questions? Yes.
I'm curious about the last line on the previous slide, that analysis needs to move more and more to data exception. What's the emergent problem there? Is it moving the data around that becomes the problem?
Yeah, certainly with the size of the data sets, I mean, you could maybe transfer it, but certainly I think we're hoping to get involved with Euclid, and we'll be a data center for that, but a lot of the analysis will be done, in-house on parallel computing center probably.
I have a similar question, because so far this is a new mantra, no move the programs, not the data. I have seen no practical implementation like this.
No, it's
one exception. How do you plan to do that? Because it's, in that way, it's just a statement.
It's just more of a statement. That seems to be how it's going to have to go, and then we'll have to react to that and build it. We had early in the VO there were models for sending your algorithms and things, but it's always the next stage, I think.
Any other questions?
So I guess you mentioned the radio surveys and the radio data. I mean, the data volumes there are just absolutely vast. So we will want to do analysis that crosses the analysis team with SK. I mean, can we really centralize that all in one place and then put our software there rather than work with distributed data sets?
It's up in the air, but I mean, that's the plan. I don't think all the data will necessarily be in one place. You'll still be trying to, if you can get the distributed querying working across the archives, you won't have to have all the data in one place, but I don't think you're going to be able to move it all around to everybody. So it's a problem.
Okay, well, thanks very much, Mike.